All right. Welcome to Code Along 3. I'm Jasper. And this is the Code Along for Polymorphism. If you want to code along with me, you can clone the stencil from the website, which should be under the Code Along section right next to where you found this video. And you can clone it from there, and we can get to coding along. All right. So a little backstory for our program. We are throwing a party. And so every party, of course, needs music. And when we have music, we need a DJ. All right. And so in our party constructor, which is where we will be working, or one of the places we'll be working, we have our DJ Lefty, and we have four of these devices that Lefty will work with. Yeah. So we have a CD player, an iPhone, a radio, and a microphone. Let's check them out one by one. So in the CD player class, we have a method called play CD player, a method called wipe CD, which is called in there. And then we have these methods plug in and turn on. Plug in, CD player has been plugged in. Turn on, CD player has been turned on. All right. What else was in there? The iPhone is another device. So in the iPhone class, we have this method play iPhone, which searches something on Spotify, which is a method inside of iPhone, a helper method. And we have plug in and turn on. iPhone has been plugged in. iPhone has been turned on. All right, let's keep going to radio. All right, radio has this play radio method where it adjusts the antenna. And it also has plug in and turn on. I feel like I've seen those before. Radio has been plugged in. Radio has been turned on. All right, last but not least, microphone. No other method, right? But it does have a plug in and a turn on method, which following the pattern, microphone has been plugged in, microphone has been turned on. All right. Well, I think it's about time that we start this party. Okay. So let's go into party and let's give the DJ some devices. So Lefty. Oh, but what can Lefty do? What can a DJ do? So let's go into the DJ class first and look to see. All right, we find two methods here. Play request and setup device. Setup device. I think that's how Lefty is going to start this party. So let's have Lefty call setup device. And I want Lefty to set up an iPhone. So I'll give Lefty iPhone here. Uh-oh, we have an error. Now take a second to think about why we have this error. If you want, you can look at the setup device method, refer back to it, see if there's any discrepancies with how we're calling it. If I hover over, I find that it expects no arguments, but it found one. And so what that means is that setup device, actually, if we go check, it takes in no parameters, right? But when we call it, we are giving it a parameter. We're giving it an iPhone. So I guess we should give it an iPhone. Setup device takes an iPhone, my iPhone. Cool. And then I guess if we want to turn on the iPhone, we should plug it in and turn it on. So let's my iPhone, and then call plug in, and then call turn on. There we go. Cool. And we have some other devices to do that for. So I guess we should also set up the radio. Set up device, Lefty, radio. Wait, there's another error. Take a second to think about why this error might happen. I have an idea. Set up device, we just made take an iPhone, right? But now we're giving it a radio, and those types are not synonymous. So we're going to have to, I have an idea. Now, to preface this, it might not be the best of ideas, but it is an idea that I think might work. I'll probably come up with a better idea, though, later. Let's go back into DJ, and let's make a new method. Public void, set up radio. And it'll take a radio, my radio. And if I remember correctly, radio has those same plug in and turn on methods. So we can call my radio dot plug in and then my radio dot turn on. All right, cool. And then if we reset this to set up radio, all of a sudden the error is gone. You know what? Let's keep going down this path. Let's set up a CD player. Lefty or left CD player. Oh, now why is this red? Well, it's red because it does not exist yet in DJ. So let's make that method. Public void set up CD player. CD player, my CD player. There we go. And just like the other two, we know CD player has which two methods? Plug in and turn on. And if I remember correctly, there's one more device, microphone. So why don't we just make another method in DJ for that too? Set up mic. And it'll take in a microphone, my mic. My mic dot plug in, my mic dot turn on. All right. Now let's go back to the party and let's have lefty set up. And as you can see, the error went away because we created that method. Set up mic with lefty mic. And well, let's run this code to see if it works. Moment of truth. iPhone has been plugged in. iPhone has been turned on. Radio has been plugged in. Radio has been turned on. CD player has been plugged in. CD player has been turned on. Microphone has been plugged in. Microphone is turned on. Great job. Great job. It looks like it works perfectly, right? And that's because, I mean, result-wise, it does. But, I'm not so sure that we did this the best way we could. Because this is a lot of code. And when I look at each of the bodies or definitions in each of these different methods, it feels like they're kind of doing the same thing, right? Let's take a moment to think about if there's a different way maybe that we could look at and organize our methods, maybe in a hierarchical structure that could result in us needing less code, really generalizing these methods. Take a moment, because I have an idea. Why don't we make an abstract class? When I looked in the beginning at iPhone, right, and microphone, and radio, and CD player, they all have these methods, plug in and turn on. And in DJ, those are the two methods that we call on them. Now, they also do basically the same thing, right? They print out device name has been plugged in, device name has been turned on. So now I am going to think about what a setup for this would look like. Now, if you're following along, I think it's a good idea that we make an abstract superclass that can take the functionality, the shared functionality of iPhone, microphone, radio, and CD player and use it in DJ to set up device. Take a moment to maybe visualize what a diagram might look like for this. All right. And I will share my idea of what a diagram could look like for this. Okay. Here we go. All right. We have electronic, or I think I'm going to call it device. But that is my abstract superclass, right? And we know it's abstract in our diagrams because it's italicized. And I have iPhone, CD player, radio, and microphone all pointing to it because they are all going to end up extending from this. And two things of importance to note. I have all of these extending from it because they all share the same functionality of turn on and plug in. And also, we have electronic italicized because it's an abstract class. And we've decided to make an abstract class here because abstract classes are classes that will never get instantiated. And the idea of a device, right, is kind of almost an abstract idea, right? It's kind of iPhone, CD player, radio, and microphone are all, instantiated in this program, but we'll never have to instantiate electronic. So we can keep it abstract. Now, let's go back to the code, and I will show an example of me implementing this. So if we want to make a new abstract class, we can go here, new, right-click on the folder, go new, and then Java class, give it a name. I'm going to call it device, and then press class or enter. And it says add file to Git. I usually just press add, but you can ignore this because if you were to ever push anything, it would be added automatically. All right. So if we want to make a class abstract, in between public and class, we have to write abstract. And so that declares device as an abstract class. And if we think back to the main methods that we need, right? Well, the only difference between each class we are extending from device is this one word. And I think we can use an instance variable of it because we will need it when we're defining plug in and turn on. And so I'm going to make an instance variable called device name. Make sure to make it private string device name. And then below that, we can have the constructor of device. And well, we don't want all of the devices to have the same name. So I think it's a good idea that we also take in a string, right? String name. And then we set our instance variable using the this.keyword to name. All right, cool. And now let's implement the two methods that we are trying to generalize or abstract into this abstract class. The first one being plugin. And let me just remember how that goes. System.print. And we can almost take it exactly. The only thing that will be different is that in the front, we will call this dot device name up plus there. And so what this does is it takes this string and it uses the plus to concatenate it right in front of this string. And so that should do the exact same thing that plugin does. And then we can do public void turn on and do the exact same thing. System.out.println this dot device name plus what is it again? Has been turned on. Okay. And now we have our abstract class. Think about how we should make it so these classes extend from it. And I guess I kind of just gave away the word we're supposed to use, but in our class declaration, we want to write public class iPhone extends device. Oh, it looks like Java's pretty mad at us right now. I wonder why. Think about why before I reveal it. There are no our constructor. Oh, we forgot to give it our superclass its rightful constructor, which we do by calling super. And so what super does, I don't know what's up with my indentation right now. Let me fix that. All right, what's up with super? So what super does is that it calls on the constructor of the superclass, which here would be device. And don't worry, it's only red because it's not in the get, so that's not a problem with the actual. Okay. So in here, we have to provide a parameter, which would be the device name, as the constructor takes a device name. And so inside the parentheses of the super is we put whatever we need to fulfill the parameters of the constructor of said superclass. So we can put iPhone in there. And we can repeat this process for all of them. Right? Microphone will extend device. And then remember, put the call to super, and we can call it microphone. Radio will extend device. And then once again, call to super, radio, and last but not least, CD player will extend device and call to super. Okay. Now, think about if we have any repeated code. Because device, right, it already declares and defines plug in and turn on, which means that CD player has access to those two methods. So we technically we no longer need plug in and turn on. So we can say goodbye to those. In all of these, goodbye, 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 and goodbye. All right. Now you may ask, well, microphone now has nothing in it, right? Why do we even need to make this a class? Well, we still have to instantiate microphone because later on we might give microphone some sort of functionality. And so we do need an instance of a microphone in our class. So if we're going to instantiate something, we have to keep it a concrete class. Cool. And now, last but not least, let's return to DJ. We no longer need to call setup device on iPhone, my iPhone, because we know that now iPhone, microphone, radio, and CD player all share the same plug-in and turn on methods through their superclass. So instead, we can call setup device on device, my device, and call my device.plugin and my device.turn-on. And as you can see, there are no errors because device has these two methods. And if we do this, well, then we don't really need any type specificity methods like setup radio, setup CD player, or setup mic, because we know that iPhone, mic, radio, and CD player are all of type device. So back at the party, well, we could just do this. And these take, right? Setup device takes a device. But because lefty iPhone is an iPhone and an iPhone is a device, well, lefty iPhone is a device. And lefty radio is a radio and radio is a device. So lefty radio is a device. And the same goes for mic and the same goes for CD player. And now let's see to check if our code still runs the same. iPhone has been plugged on. iPhone has been turned on. Radio has been plugged on. Radio has been turned on. CD player, yada, yada, yada. Yay. Great. All right. Now our party is all set up. But I think it's time to, let's play some music. All right. So if I remember correctly, DJ has this play request method. So I guess we should go into party and let's tell the DJ, hey, Lefty, can you play requests? Can you play? Let's play on the iPhone, Lefty iPhone. Can we play Nothing Like You by NetSpend? Uh-oh. We have an error. Oh, I feel like I've seen this before. We don't give it anything. All right. Let's make it take an iPhone. My iPhone. and a string song name. And then in here, well, if I remember from when I went through all of these classes, iPhone has a play iPhone method that takes in a song name, which plays the song. Oh, cool. So now let's go to DJ and let's tell it, all right, take that iPhone and tell it to play that song. And so this should work. All right. Well, just out of an iPhone, that's probably not enough sound. So I guess we should also play the radio. Lefty dot play request. Lefty radio. And then we can play, Hit the Quan by I Heart Memphis. Why is that red? Oh, it's because it takes a radio, or it takes an iPhone. We've provided a radio. Well, okay. Well, then let's go and just do public void play request on radio. And we can do radio, my radio, string song name, my radio. And let's check my radio to see what it, oh, play radio. Look at that. My radio dot play radio song. Wait a minute. I think this is going to work, right? But I also feel at the same time, right? Play request on radio. This kind of feels like what we had here initially, right? In DJ before we just had one setup device method, where we had one method for every single instance, right? For every single different object, for an iPhone, for a radio. Oh, wow. You know what? There's got to be a better way we can do this. Take a moment to think about a better way. I have an idea. Why don't we just make it so every device, right, can also play a song? Because iPhones can play a song on their device, CD players can play a song on their device, radios can play a song on their device, and microphones their device. And oh, that didn't work. All right. Take a moment to think if there's another thing that we could do. Because as I'm looking at these different methods, I'm kind of realizing that we'll play CD player, it wipes the CD. Well, the iPhone, it searches on Spotify, and the radio, it adjusts antenna. So those methods aren't even that similar. What kind of what should we use to maybe connect these and maybe make it a little more general? I think I have an idea. I think we should use an interface, right? We can make an interface, maybe call it playable, because radio can play stuff and iPhone can play stuff and the CD player can play stuff, but they all do so differently. And I know that we're supposed to use interfaces whenever we want to make or have the same method call with different method bodies or definitions, right? They all play something. And in DJ, I kind of just want to play something. I just want to play a song, but they all do so differently. Now, also think about how that would look in our already created diagram. All right. 3, 2. All right. I'm going to show it now. If I scroll down, we can see. Oh, hopefully that's not too big. All right. Yeah. So we now have our, just make it smaller. We have our original diagram up here, but now I've added this playable interface. And so on diagrams, the interface is represented by a circle. And then like whatever the name is, you can put it inside if it fits. If it doesn't, you can put it outside, but I think it's better if it's inside. And then lines between that and whatever classes implement this interface. And so I have iPhone implementing it because iPhone has a play iPhone method. And so that can play stuff. CD player can also play stuff. It's almost in the name. In radio can also play stuff. So I think all of these should implement playable. Cool. All right. Well, now I think we should let's implement the interface. Let's go back to the code. All right. And let's make an interface. So you do this by right-clicking on the folder, going to New, and then Java class. And then below class, there should be an option for interface. So we press that, and then we give it a name. I'm going to call it playable. And add it to get, I don't really, X. Okay, so now we have this interface. And now think about what goes inside of interfaces, right? Do we need instance variables? Well, nothing in the interface is really there's no bodies, there's no or definition to any of the methods. So we can't really call upon an instance variable. Do we need a constructor? Well, once again, there's no we can't call a constructor on an interface because we can't have an instance of an interface. And there's no instance variables so we have nothing to set up. So I don't think we need any of that. All we really need are the declarations of the methods that we will need in the classes that are going to implement it. Well, a playable needs to be able to play a song. So let's declare it. Public void play song. And like all of our play methods, we can have it take in a song name. Cool. And should we end it like this? No, right? Because in an interface, we don't have any method definition. So anything in here does not belong in an interface. Rather, we just want the declaration. So we end every declaration with a semicolon. Cool. All right. And so now we have our playable interface. Now I think it's time that we implement it. So we can start with iPhone. What is the keyword? I've been saying it a lot. It is implements in our playable interface. Cool. Oh, it's red. Does anybody know why it's red? Take a second to think or pause the video. You can always pause the video. Exactly. It is red because we do not actually define this. So we have to, well, here you could, right, make a whole new method. The important thing is that it has to have the exact same method header, right, or declaration, method declaration. So it would have to be public void play song, and it has to take in a string. The actual variable name doesn't happen or matter, so I can do that. And all of a sudden the red goes away. But here we already have a method that kind of does the same thing in play iPhone. So I'm just going to replace play iPhone with play song. And the red goes away. And we're good. Are we good? Is there anything I'm missing now that I've implemented this? Yeah. What we're doing is we're overriding this method declaration in playable, right? And so we need, by filling out its definition, we're overriding it. So we have to give it this at override above. And now we're good. All right. Let's do that same thing for everything else that's playable. Microphone, not playable. Radio, playable. All right. Implements playable. Oh, it's red. Play song. And now it's not. And as always, at override. Cool. And then we can keep on going to CD player. Extend device, implements playable. Oh, play song at override. All right, cool. Now, if we go back to DJ, right? Oh, these devices, these methods don't exist anymore. Well, I think I can do instead of that, play song, right? Okay, that works. And well, I don't want to just take an iPhone now. I want it to take a playable. Playable, my playable. And then on that, we can call play song. And that there's no errors. Okay, let's see if it actually works though. Let's go back to that party, right? And let's play request on everything. Let's call it on lefty iPhone, lefty radio, lefty CD player, or it's just left CD player. And well, we don't have anything else. And I guess for the last song, we can do um uh we'll do alternative outro by Lucky. Yeah, I think we can do that. All right. Now let's see if everything gets printed out correctly. Do you think we did it? I hope we did. Let's go to our app class, hit play, and see iPhone has been turned on. All right, all that we know. All right, searching Spotify, playing Nothing Like You by Ness. Yes. Battery at 99. Cool. Adjusting the antenna for the radio, playing Hit the Qualm by iHeart Memphis from radio. Cool. Wiping the CD for alternative outro by Lucky. Playing alternative. We did it. Yeah. And so I guess now to go over everything, right? We have our device abstract class, and we chose to make an abstract class because we had a lot of overlap, almost exact overlap between these two methods, right? Plug in and turn on, where they did the exact same thing except for one word. And so that one word, we just made it an instance variable that we could then pass or like use in both of these methods. And we made this an instance variable because it had to be used in multiple places. And so the scope matches the scope of this variable, right? And then we have then we use that in iPhone because iPhone originally had those two. And so we call super to instantiate all of the instance variables in this device and make that implementation work. And we do the same for microphone, and we do the same for radio, and we do the same for CD player. And we do the same for all of these because they all have or all had that turn on and that plug-in method. And they were basically the same. So we could take those and shove them to a superclass, right? And now a CD player, an iPhone, a radio, and a microphone, they all have and is a relationship with a device because they can all do everything. It can do everything a device can do exactly as the device would do it. And now we have the other issue of play song, where CD player, iPhone, and and radio all had their respective play song, whatever, play radio, play iPhone, et cetera, methods, which we were intending on using, and this is important, we were intending on using them in the same way, right? Just in this play request method. But they all had very different functionality respective to which version you were actually, right? If you're calling the iPhone or the radio or the CD player one. And so instead of making a superclass, right, which would then make it so that all of the methods were defined the same in each, or we would define the method in the superclass, which would make it so the radio would play the song the same way the iPhone would, which would do the same way the CD player would. We wanted those to still have those different aspects. So we instead made an interface, which then just declared this play song method. And so when we overrode that method in radio and in iPhone and in CD player after implementing playable, we could then call this method on an instance of a playable in DJ, right? And we could then pass in party, we could pass in an iPhone, a radio, a CD player, or a mic into this method, because we know that they are all, or not a mic, just these three, into play requests, because we know that they are all they all act as a playable object, or yeah, And so we have that confirmation that they all have this method. Great. Cool. And it all works. It all works well. And we could there's something to be said about making these changing the declared type into device. And that goes into the idea that if I were to make all of these devices, well, then I couldn't play request because device does not implement playable, which touches on the difference between the specificity and the generality. But yeah, I hope all of this made sense and you can kind of see some sort of parallels and understand more about when to use interfaces and when to use abstract classes and when to use superclasses, and the difference between all three, and how much really it's all about the sleekness. Because if we didn't have these two, or we didn't use polymorphism here, we would have 4 methods for this one method and 3 for this. So we really turned 7 methods into 2, which is much more appealing to look at and much smoother and sleeker coding. Yeah. Thank you. I hope this all makes sense. And if you have any questions, always feel free to come to office hours. We love to clear things out.